All right, the next thing we can look at is we can use binary beyond just it representing a number. So we usually refer to these as we can say that we have some type of binary coding. Okay, so let's look at a couple of different examples. Some of these are standards, and some could be coding that you come up with on your own. Let's say we were going to represent colors as a binary code. Okay, so let's say we have a couple different colors we want to do. I have a red, I have a blue, I have a green, I have a yellow, I have a pink, I have white, I have black, I have brown. Let's say these are the colors that I have. So how many different options do I have? 1, 2, 3, 4, 5, 6, 7, 8. I have 8 options. 8 options is, well, 2 to the 3 is equal to 8, which that tells me I need 3 bits. So let's give each of these a binary value. Then we give red all zeros, blue is 0, 0, 1, green is 0, 1, 0, yellow is 0, 1, 1, pink is 1, 0, 0, white is 0, 1, 0, 1, black is 1, 1, 0, and then brown is 1, 1, 1. So I can have a set of 3 bits code a color. So then let me say if I have 0, 1, 0, I know that always means I have green. Okay, so that's one way you can do it. Now we're going to talk about some standards. One standard that if you do anything with a computer, we know that there's such a thing called ASCII. And this is going to be a binary code for text characters. And this will be anything that will show up in text. It could be a space, a hashtag, a minus, a plus. It could be a new line, a tab. So there's everything that could possibly make up text. Well, we could have our letters. And in our letters, let's say I have capital A, capital B, capital C, capital D. Well, I need some type of coding. This is going to be set up as ASCII coding. And these will be, for A, that's binary 1. And then it has 5 zeros. And then it has a 1. And this is 65 and a decimal. Well, then what is B? B will get the next number over. The next number over will be 66 in decimal. C would get 67 in decimal. D gets you 68 in decimal. So you can have some type of coding to represent what letter it is that I want. Another type of coding we have is called BCD. This stands for binary coded decimal. And let's say I have something like 3,213, and I want this instead of a binary number. What is that number in base 2? I want to take this and I want to code each digit. We want to code each decimal digit with a 4-bit number. And the 4-bit number I'm going to use is I'm going to do that the decimal 0 should be as a BCD 0000. 1 should be 0001. 2 should be 0010. 3 is 0011. 4 is 0100. 5 is 0101. 6 is 0110. 7 is 0111. 8 is 1000, and then 9 is 1001. And here, this is where we stop because there is no 10, 11, and 12 if we're just talking about decimal digits. So now I have 3, 2, 1, 3. I'm going to take this first 3, and that's going to be made up of 4 digits. That makes up the number 3 on this table. That is 0011. Then I'm going to take the next one. This 2, that's also 4 digits. 2 is made up of 0010. Then we take a 1. 1 is also 4 digits, 0001. And then we're back at this 3, and it's 0011. So that's a way that we could take each of these digits, and instead of converting it directly to a binary number, I take every decimal digit, and I represent every decimal digit as a code. So I know this ends up being a lot more bits than I would take as a binary number, but it might be easier for me in the problem I'm trying to solve to keep everything as decimal. All right, so that's what we can do with binary besides saying it's a number. I can use it as a coding scheme.